Hello, this is Professor Gavoor. We're going to talk a little bit more about software. Software in Flux, open source cloud, and virtualized and app-driven shifts. I'll probably talk more about the learning objectives this time. I guess maybe every other time I talk about it a little bit more. But we want to understand how low margin costs and network effects and switching costs have combined to create a huge and important industry. Well, that and the fact that the proliferation of computers, the investment in capital and technology has reduced the need for people in many organizations. And that's really what drives it, to be able to do more with less people. And the fact that the software doesn't take sick days as much. I mean, it still has times where it needs to be fixed and attended to. Recognize the software industry is undergoing significant and broadly impactful change, and this is brought about by increasingly adopted technologies, including open source software, cloud computing, and software as a service, which we'll talk about a little bit. So, marginal cost, the cost associated with each additional unit being produced. For software to do one more transaction once you've invested in the software is nothing. I mean, it's really small. Open source software is software that's free, where anyone can look at it and potentially modify the code. Usually that doesn't mean the base software, but like in something like Python and R, it means writing your own code to do specific things, and then you share it with everybody as you see fit. Cloud computing, replacing computing with services provided over the internet. In other words, instead of doing things on your desktop or a server that you're owned by yourself, this is what allows everybody to work from home. The ability to access your servers, your own company servers or servers owned by third parties with your software and your information, ability to do your work. The ERP system is available through the internet. That's cloud computing. Software as a service is a specific form of cloud computing where the firm subscribes to a third-party software and receives a service that is delivered online. In other words, even SAP and Oracle have software as a service. And I think the most recent version of SAP HANA is software as a service, from my understanding. Virtualization is technology can make a single computer behave like many separate computers. Helps consolidate computing resources and creates additional savings and efficiencies. So learning objectives for the next section is define open source software, understand how it differs from conventional offerings, and provide some examples of open source software and how firms might leverage this. So Linux is an operating system that's open source. The source code for the operating system products is openly shared. Anybody can change it and can be redistributed by anyone. This is in stark contrast to like MS-DOS, which was the first one on personal computers, or the operating systems that operate on Windows computers, or the operating systems, and DOS is still somewhere, I think, in the background of Windows computers, and the operating system on Macs. So this is a separate operating system that you can use, and a lot of times people will use it on microprocessors or other devices. They almost never, like this is in stark contrast to conventional operating systems, where treat their intellectual property as closely guarded secrets and almost never provide the source code for their commercial products. It's seen by some firms as a threat that undermines the economic model, but Linux has been around for a long time, and so has the Apple operating system, so has the MS-DOS operating system, or the Windows-based PC operating system. So I don't see it as a threat, really. I think there was a threat at the beginning. So here's what they say: turn on the lamp. It's for free. Well, LAMP is an acronym that stands for Linux, which we just talked about, Apache Web, Server Software, which I'm not as familiar about, MySQL, SQL, which is a database kind of language, which a lot of SAP, I mean, I remember hearing our SAP people that were more coders and programmers talk about SQL all the time, SQL, pronounced SQL. And then there's several programming languages that start with a P. Python is the one I'm a little bit familiar with, but also R, which is this open source statistical software. So I guess some of this stuff powers sites that are visited every day from Facebook to YouTube. So there seems like every other slide is a learning objective here. Know the primary reasons firms choose to use an open source system, and understand how open source can beneficially impact industry and government. Well, why open source? The cost. Free alternatives to costly commercial code can be a tremendous motivator. Reliability. The more people who look at the program's code, the greater the likelihood that the error will be caught and corrected. Security. By allowing many eyes to examine the code, the security vulnerabilities to come to light more quickly and can be addressed quickly. So security focus. Technologies operate that contain particularly strong security features. The other thing, the cost is real. R quickly replaced almost all statistical packages. I mean, some of them like SPSS and SAS and other Minitab and other things can be quite costly to buy, as an enterprise license, or to do some significant stuff. Plus, R has no restrictions on the size of the database, which makes it perfect for big data. So when big data starts to hit, and R became a free statistical software that could do big data, boom, it took off like crazy. And while people are looking at the source code, which I probably would never do, people like me would be writing their own software or routines or programs that I would use to do my work. And if I wanted, which many people do, they share it with others. Like I told you last time, I do some life data analysis earlier on in my career, and I did programming. So I looked on R to see what was available. Everything I had programmed and more, way more, back in the 80s on a 10 megabyte IBM desktop was all available here. And you had several choices of different softwares to use. So it's pretty cool stuff. Scalability, the ability to handle increasing workloads can be easily expanded to manage the workload. It's that easy. You just download it on your computer and you're ready to go with the R. I have it on a couple computers, and I just don't use it much because I don't have a need to. Agility and time to market. Vendors skip the whole segments of software development and allowing new products to reach market faster. And in fact, R and Python are kind of interesting, is that there's just a ton of applications out there written in these two softwares for big data analysis that are freely available. You don't have to learn to program anything. You have to learn to know what you're trying to do and then look for something and see if it... I've found out that a lot of big data people do little programming and more do Google searches to find out what is available that kind of does what they want. Maybe they modify it, maybe they use it as is. They try it. If it works, they keep using it. If they try it and it doesn't work, they don't use it. So it's kind of interesting. Why the open source army doesn't show up. I'm not, this is a lesson from a company called Heartbleed. Many open source projects are very well maintained with tightly coordinated contribution armies overseen by well-funded and paid professionals. So back in 2014, some open source products which had been woefully neglected were exposed to the Heartbleed bug. So it's not a company. I'm sorry. I thought it was. Heartbleed was an error in the open source security toolkit, a product produced by some 2/3 of the internet websites and underpinning security related when sending secure information over the internet. The routine coding error opened a hole that could potentially have been used to allow hackers to gain passwords. So I guess the same people that are using the open source software can be the bad people. So to get people's passwords, encryption keys, and other sensitive information, triggering the largest security breach in the history of the human race. I wasn't even aware of this one. And maybe we'll discuss it more when we talk about cybersecurity. The foundation, Linux Foundation, developed a multi-million-dollar project called the Core Infrastructure Initiative, and it was designed to fund open source projects that are in the critical path for the core computing functions. So Heartbleed provides a cautionary tale to managers. Just because the tool is used by many doesn't mean one shouldn't audit its software products to understand the strength or support the potential risks associated with the use of such. It's a buyer beware. If it's free, you've got to be careful. And you should still have protocols in place to protect yourself when you're running the software, and make sure that you have good cybersecurity software engaged with your development people and your day-to-day operations. I mean, that is a risk, certainly, of all cloud and all internet-based computing. And these free open source softwares are used primarily in that format. So here's some more learning objectives. Recognize that just about every type of commercial product has an open source equivalent. Be able to list commercial products and their open source competitors. So, examples of open source software. Firefox, which is a web feature that I use all the time. In fact, I probably have it open right now. I'm familiar with MySQL. I'm looking at these others. WordPress certainly, but I found WordPress cumbersome to use, so I use Blogger, which is a Google product for mine. But that's just was my problem. Sugar CRM, I'm familiar with. It's a customer resource management program. I dabbled with it a bit. It's okay. It wasn't as easy to use. Some of these things require some real learning to know how to use it. So I'm familiar with Firefox. I've tried WordPress and Sugar CRM, and know about SQL for sure. And the others I'm not as familiar with. So we want to understand a disproportional impact open source software has had on the IT market, and understand how vendors make money. Well, I know how vendors make money is if it's not easy to use, they will help you. They'll make it easier to use. They'll write programs that sit on top of these things and make it easier for you for it to be more intuitive. So why give it away? Well, it lowers the cost of computing and makes computing options accessible to smaller firms. Oftentimes it's reliable, secure, and lowers computing costs, even though we just talked about the security breaches that could happen. It diverts funds that can be used for other competitive initiatives and encourages innovation. So instead of spending time writing your own software, having someone write software for you, you might as well use this stuff and modify it. Vendors make money by selling support and consulting services. Like I said, they're not all easy to understand. Industry's evolution as a standards competition. Pre-Linux days, almost every hardware manufacturer made its own incompatible version of the Unix operating system. As such, they had difficulty attracting third-party vendors to write applications. Now all major hardware firms run Linux, resulting in a large unified market attracting software developers. So Linux on the desktop is common on mobiles, consumer electronics, and on enterprise solutions, but not on desktops. It's not easy to install. Its complexity can raise the total cost of ownership. And total cost of ownership is something you got to look at. It's all the costs associated with the design, development, testing, implementation, documentation, training, maintenance of a software system. So the two major ones that people use on desktop or laptop computers are the Windows-based operating system and the Apple-based operating system. And because of that, I mean, like, and a Windows-based, I can certainly use Windows Office Suite. I can't really use the Apple Suite, but I could use the Google Suite on any operating system. And on my Apple, I certainly have the Windows Suite of Office products at the same time. Over time, the two systems have converged. In fact, I have a Windows-based laptop, and I have two Apples that I use that I can switch back and forth to, and it's seamless to me. A legal risk in open source software. So here's some the hidden challenge that they talk about. It's not without risk. We've talked about that. A major concern is legal exposure. Firms that use open source software could be at risk if they distribute code and aren't aware of the licensing implications. Some commercial software firms have pressed legal action against users of open source products when there is a perceived violation of software patents or other unauthorized use of their proprietary code. I doubt that any of us that are in this class, I mean, this is not an IT major. We're not coders, we're not application developers, but as managers, we'd have to watch out and make sure that the application developers that we use aren't cutting corners and maybe having us as managers, the companies that have hired these applications developers, to be at risk. So you probably want to put that in your contract when you're when you're hiring an applications developer, to make sure that this kind of thing is not being happened. So you probably need lawyers that are well versed in this kind of law to make sure that your contract, if there's any legal liability, it's not going to you, but it's going to the application developer. Assumes all those risks. But you may have to shut down using your software and need a backup. So it just make sure you do it right if you can. Also, there's other issues. They go by various names, the GPL and the Apache license, each one slightly different with legal provisions. Many have evolved over time. So you've got to look at what you can and cannot use and distribute and make money at. I don't think it's a big issue, but it's something that you've got to manage. Yay, more learning objectives. Understand the concept of cloud computing. Identify the major categories of cloud computing, including software as a service, PaaS, and IaaS. So there's two basic categories, or separate categories. One is software as a service. So it's utility computing. Firms develop its own software and then run it over the internet on a service provider's computers. Include variants, which is platform as a service and infrastructure as a service. Some people are developing their own private clouds, pools of computing resources that reside in the organization and can be served up for a specific need. Why would you want to have your own private cloud? Because you don't want anybody, it minimizes the ability to hack into it. More and more, since I started teaching at North Park, like I talked about the course that I teach, managerial decision making, quantitative analysis for managers. We use a bolt-on add-on to Excel that allows us, that has the algorithms to run in Excel all of the topics that we cover in the class. Well, not everybody's work computer allows them to install this for various reasons. They don't want to have third-party softwares that are not approved by their IT, and maybe opening a door to their private cloud or their own internet web, and provide just an input into their company that could allow a hacker in. So many people end up having to use a personal computer when they do their classwork in that class. The evolution of cloud computing has huge implications over the industry. It's the financial future of hardware and software firms. You don't have to own the software. You don't actually have to install it on your systems. Um, so the cost structure and innovativeness of adapting organizations, they make a change. I mean, when is, and this is more historical than it is now, when was Microsoft going to do an automatic update of uh, your Office suite? Probably when you're crunching for a project with a tight deadline, you're a little bit behind. You used to get these annoying updates that would occur and your computer would be unavailable to you. Well, if you use like Apple or Google Drive, as a Google Drive especially, the changes are just made automatically. You don't have that software on your computer. It's cloud-based from Google. It's software as a service, and it can do a lot of what Word and Excel can do, but it's updated by Apple behind you, behind the scenes, and you don't even know. I mean, there might be an occasional email that tells you we have new features and here's what's available, but most of the time you just sense it in a menu change. It's quite easy to do. I thought it was going to be a huge challenge to Microsoft's Office suite when it first came out, but as many things Google does, it really hasn't. They haven't pushed that. So cost structures and innovativeness for adopting organizations, skill sets likely to be valued by employees. The more you can make it easier to do these changes in cloud computing and these updates can happen without you even noticing it. Transparent to the user, which is a term that I've been using a lot. So know how firms using software as a service products can dramatically lower several costs associated with their information systems, and how software as a service vendors earn their money. From the ones I know that are for-profit companies, they charge you a fee. I mean, if you use Intuit, QuickBooks, and there's a software as a service or a cloud-based version of it, you have to pay them to use it. And if you haven't kept up, you don't use it, period. So be able to benefit from the vendors, be able to list the benefits to vendors from deploying software as a service. So why buy when you can rent? This is the case. Most software as a service firms earn money via a language-based pricing model, or usage-based, pricing model, similar to a monthly subscription. You're going to spend thousands of dollars to buy a site license that has to be renewed every year anyway. Why not just rent on a monthly basis? I'm not sure how much I'm going to use, how much I'm going to need. These things are scaled. So Salesforce is a CRM system, and it's cloud-based. Why do I need to use it? If it integrates well with everything else I do, why not just use the cloud-based one? And for smaller companies, this makes a lot of sense. For Fortune 500 companies, it's probably going to make more sense moving forward, but they may want to have it resident on their own servers. I don't know. So other SAS, software as a service firms, offer free services that are supported by advertising. Promote the sale of upgraded. The other thing is you can try it, you like it. A lot of them have a free version, and that might be a little wonky sometimes and not do all the stuff, but if you want to just see, hey, I really like this, I think I could use it, then you could buy in. And this is perfect for, it seems like when I was doing more consulting work than I'm doing now, my company, CR Supply Chains, I got offers all the time for software as a service. Try it for free, try it for free, try it for free. A few of them I tried a CRM system. I really probably needed the volume of business that I could have had someone come in and a consultant help me with it, because I didn't have the time or the wherewithal or the desire to master setting it up and making it work, and it wasn't intuitive enough to just be obvious. You want to promote the sale of upgraded or premium service. So everybody's seen this. Hey, use the free version. Great. and they're always trying to sell you the other one. The ones that work the best for cloud-based services are Dropbox and Box, because they offer you free services, and they know that you're free until you use up the free amount of storage space. And as soon as you do that, you got to decide two things: do I pay for it, or do I not? It cost me $100 and something a year for both Box and Dropbox, but I use Dropbox because I put a lot of photos on there, especially for I write articles with other people for a sporting event that happens every Labor Day weekend, and I just dump tons of photos in there. So the first year I did it, I ran out of space. So I paid for that, and it's worth it. All the photos are there, and I just keep the maintenance fee going. Box I use for all North Park activities, and I just load all of my PowerPoints, all of my course materials, and I pay for a file cabinet basically that I can access from any computer anywhere. I have, like I said, I have 3 laptops, one issued by North Park and 2 of my own, one of my own, and a desktop at home. So I can access and change things and do it from anybody's computer. And if those 3 computers are not available for some reason, I can use anybody's computer that they give me permission, of course, and probably access to it, to access online my box.com files and be able to update the class and teach the class. Canvas is a cloud-based learning management system that we use. If you're watching this lecture, you're in the cloud right now, enjoying it. Did I just say enjoying it? Well, that might be a stretch. So they compete directly with the biggest names in software. And guess what? The biggest names in software don't sit around and let these other people eat their lunch. SAP and Oracle have software as a service type systems available too. What are the benefits of software as a service? Lower costs and financial risk mitigation. I don't have to have a service to use it. If I have a small business and I have a laptop and I'm running my small business on a laptop, I can use the QuickBooks software as a service version. Some people actually operate it from their phones. It seems like the more serious things get, I want to have a full keyboard to use, but I think that's a bias of being older. Younger people are happy to do as much as they possibly can on their phone. Faster deployment times and variable operating expense. You have scalable systems, higher quality and service levels. I'm not sure about that. I don't know if it's the same company that offers both, which is superior. I would think that if I'm using SAP traditional, just on my own servers and all of that, I'm pretty sure it's going to work reliably, and I'm pretty sure it's going to work reliably in the cloud. Limits development to a single platform. That's important. All your work is done in one environment, and having all your data in one location and accessible, assuming that you back it up on a regular basis, and it's secure, is a good thing, because you want to be able to access all your data and integrate it as needed. Tighter feedback loop. I'm not sure what they mean by that, but I think it has to do with your ability to get responses to things. Either it's going to be good or bad, depending on your internet connection. The whole thing here, I think, is dependent on, do you have Wi-Fi? If your Wi-Fi goes down, the whole world comes to a screeching halt. And Wi-Fi does not go down that often. So it's good to know. But if Wi-Fi goes down, we're in trouble. Lower distribution costs. If you add another user, you just give another password. Sometimes it might limit you to 10 users, and then charge you a little bit more, but that's a subscription service again. So you use what you need. That's what the some of the benefits of SaaS are too, software as a service, and reducing software piracy. Yeah, I guess it could. If you developed your own, people could steal it, but one source of security, it's in one secure. If it gets hacked, it gets hacked for lots of people. But it's easier to protect one fort, I guess, than to protect several forts. Be able to listen and appreciate the risks associated with software as a service. So it's not without risk. You depend on a single vendor. Well, if the vendor's been around, if it's someone that's new and a startup and all that, that could be a concern. If it's Intuit and it's their QuickBooks product, they're not going anywhere. SAP's not going anywhere. Oracle's not going anywhere. And you're going to know about any risks that those companies have probably long enough in advance to be able to do something about it. The problem is when you get these kind of operating ERP kinds of systems that you run your entire company on, it's kind of hard to implement them the first time and get everything running the way you want it to do, and then add new functionality that usually you're going to add the functionality that comes with those companies, cloud-based or not cloud-based. It's almost, once you walk into the door of SAP or QuickBooks for smaller companies, or Microsoft's version, or a variety of other, it's pretty hard to switch from one to another. The incentive is to stay. It's almost like the equivalent of an airplane, airline frequent flyer program. If I'm on American Airlines and happen to be a platinum level or executive platinum level, why would I fly any other airlines? I get all the perks on that airline. The switching to another airline would start me at ground zero, and I'd have to build up and go through the gold and silver and platinum and then the executive platinum equivalent award structures on those airplanes. And I'm not about to do that. So I'm a devoted, price being the same, American Airlines customer. In fact, having in my work life accumulated 2 million miles, I'm a lifetime platinum. Why would I switch airlines? I get too many benefits. I get to board the planes early. I get free luggage. I get for life. Who's traveling anywhere now? But I still have it when it opens up, assuming they don't change the rules of the game. But the same thing applies to this, the same kind of principle. Once I'm an SAP person and I've got it stabilized and running, to switch to Oracle would be almost an idiotic financial move and an idiotic operational move. It'd have to be some real strong reason for me to switch. And that applies to whatever ERP system you're using. I think smaller companies can do it quicker and better because they probably aren't using all the functionality of their ERP systems anyway. But again, they're not going to want to go through all that trouble. No one does. Users may be forced to migrate to new versions, but you want to do that because, as we talked last time, you want to make sure that your software has support. If you don't upgrade to the new version at some point, like I said, you're going to get an email that says, hey, listen, your version 1.2 we're not supporting anymore. If you don't upgrade to version 3 or 4 or whatever they're at now, or 4.2.1, we will stop supporting the software you have and can't guarantee that it will work effectively for you. So reliance on network connection, which may be slower, less stable, less secure. You need the Wi-Fi or a network connection to make it work. But guess what? All of business requires that today. It's almost impossible to do business without. I mean, if the phone lines and Wi-Fi go down, I think retail stores are only going to operate on cash. I don't know that they can process credit cards without. Can they? Someone in retail has to tell me that. Limited configuration, customization, navigation, integration options compared to packaged software or alternatives developed in-house. I don't know if that's really true. I would think in some new software as a service offerings that might be the case, but things that are more established, they keep adding bells and whistles over time, and can be offer the same exact services as packaged software or alternatives developed in-house. In fact, the only alternatives developed in-house, I think, are if you have some proprietary calculation. I work for a company that used to have design a certain kind of gearing. They were the world leader in that. They had the three people in the world that were expert at that kind of gearing, and they understood the equations. They knew what was possible. They knew the nuances. They wrote their own software, but that's a small detail. That's like the trademark and copyright and patent kind of stuff that makes your software different. But to run their business, nah. It doesn't matter. They're probably using, I'm not sure what that company is using. I haven't worked for them since the 80s, but they are no doubt using SAP or Oracle, would be my guess. User interface of web-based software is less sophisticated and lacks richness of most desktop alternatives. That could be the case. But for smaller companies, that's probably a plus, not a negative. If I was to use, I can't do, and believe me, I'm no Microsoft Word whiz or Excel whiz, but I know that I can't do everything that I can do on my desktop version of Excel that I can do on the web-based version. I don't know that I can download data analysis. If I can't do that, I've got to use the desktop version of it. So ease of adaptation or adoption may lead to pockets of unauthorized IT being used throughout a firm. Firms are always fighting this. People try to cut corners, or if they don't understand the software that you've provided and insist they use, the biggest culprit here is to try to do things in Excel. Download the data, do things in Excel, and upload things. Here's a problem with that. People try to use Excel because they believe or think the darn thing is too complicated or doesn't work. So if you allow people to start doing transactional work that should be done in an ERP system like SAP or Oracle, online, off the system in Excel, downloading the data into Excel, manipulating it, and then uploading the answers back somehow, they will continue to believe that the darn thing doesn't work, and therefore not do the data management that's required to keep the thing working. And of course, the darn thing eventually won't work. And this is a gap between the process that the people think the system should operate under and the process that the system actually operates under. So as people still are probably thinking it should be more as is than to be business process wise. This is why training and whatnot is so important. So you got to make sure that people don't use unauthorized software. There was a VP at one of the companies I worked for of procurement. Really an important job. And it was an SAP shop. And this company was everything they did was SAP. And in fact, they piloted a lot of functionality with SAP in partnership. Well, for some reason, this guy decided that the procurement software that he wanted to use was not SAP, and actually went and signed a contract. And he was fired and shown the door very quickly for doing exactly that. But that's a blatant, overt kind of thing. All right, learning objectives next. Distinguish between software as a service and hardware clouds. Provide examples of firms and uses of hardware clouds. Understand the concepts of cloud computing, cloud bursting, and black swan events. Understand the challenges and economics involved in shifting computing hardware to the cloud. So cloud offerings. if we talk about software as a service, provides the software and hardware to replace an internal information system. You've outsourced your IT to a large degree. You still need IT people because you need them to interface with the people that are providing it, but you need less of them. A firm replaces software and hardware with a service provided by a third party online. Hardware and software exist in the cloud, meaning that somewhere on the internet. You don't even have to know where. It's, again, transparent to the user. You only pay for the amount of processing, storage, and telecommunications you use, and maybe interfaces. So the more people that sign up, you may end up paying more at a certain amount. And what bells and whistles, what options you've turned on. Cloud vendors host your software on their systems. You interface with your your army of laptops in your company, your army of desktops. And you may have some servers locally just for local storage of some data that you download and things of that nature. So cloud computing efforts focus on providing a virtual replacement for a subset of operational hardware like storage and backup systems. I'm not sure exactly what happens when to large companies that do this, but I know that it's an entryway for small companies to have the same computational capability as the ERP systems of large companies. So examples of hardware cloud services are Salesforce, which offers Force.com, but I know that SAP offers the software as a service. The Microsoft version of it could be the same, as well as this Oracle family of products has some software as a service capabilities. Now, this includes several cloud supporting tools and to write applications specifically tailored for web-based delivery. Google's App Engine offers developers several tools. Microsoft offers Windows Azure. And platform as a service. So cloud providers offer services for customers to build their own applications on a provider's infrastructure. Services include hardware, operating system, tools, and hosting. Infrastructure as a service, cloud providers offer services that include running the remote hardware, storage, networking. Clients can choose the software used. So one is a platform. The other one is we provide the infrastructure, but you tell us which software you're going to use on there. So you can separate it. You can have platform, or you can have infrastructure, but you choose the platform. So, estimated monthly cost to run a website with 50 million monthly page views. Google Compute Engine, $395. Microsoft Azure, $402. Amazon Web Services, $468. Company-owned computing. Well, why is the company-owned computing so much more? Because of economy of scale. All of those other sources, Amazon Web Services, Microsoft, and Google, have an army of people. They have plenty of space, and it's just cheaper to do it with them, especially for something like a website. Clouds in action, a snapshot of diverse efforts. So, cloud bursting, use of cloud computing to provide excess capacity during periods of spiking demand. It's a scalability solution that's provided as an overflow service kicked in as needed. Black swans, events that cannot be predicted but can cause an impact. Scalable computing resources can help a firm deal with spiking impact from black swan events. What if you back up your system every day, or maybe twice a day, or maybe 3 times a day? Do you want the ability, if you get hacked, to flip a switch, much like if you have a backup generator at home and electricity goes out, the backup generator kicks in and you can operate the essential parts of your home. It keeps the refrigerator and freezers running. It allows you to have some TV and internet connections and lights and maybe part of the house, and electricity, of course, to keep the furnace running. Usually in the summer, people would forego putting the air conditioning on there because it sucks up a lot of electricity. Or you could pay a lot and just have it be transparent to the user. Everybody's electricity went out, but nothing happened to you because your generator kicked in and is providing you the same amount of kilowatt hours as you were using before. Well, the same thing could happen here. Do you want to be able to run your, bring the backup system online? The last backup that you had that was good before you got hacked, and run it on the third-party system. That seems like a lot of redundancy, but I think it's theoretically possible. So challenges remain. If you install a complex set of systems on someone else's hardware, it can be a brutal challenge. And in many cases, it's just impossible depending on the size of the firm. But boy, for a startup, it's the easiest thing in the world to do. Firms considering cloud computing need to do a thorough financial analysis to make sure it works. It's outsourcing. It's like outsourcing your factories to China. You're outsourcing your IT to somebody else. What flexibility will it give you? What restrictions will be imposed? And you need to know those very quickly and completely, and assign some costs to them. Firms should enter the cloud cautiously, particularly where mission critical systems are concerned. Well, let's say I'm a startup. I can start using cloud-based services and not have to have that infrastructure. So it's, do you want to, maybe later as I grow and if I become a huge corporation, I might want to bring more of it in-house, but at the beginning for a startup, I think the cloud is the only way to go. So in the next section, we want to talk about how cloud computing's impact across industries is proving to be broad in significance. Know the effects of cloud computing on high-end server sales and influence on the trend shifting from hardware sales to service sales. Knowing the effects of cloud computing on innovation and influence. And knowing that by lowering the cost to access powerful systems and software, cloud computing can decrease barriers to entry. And I've been pointing that out all along. Understand the importance of size and metrics of server farms. Just to get a scope feel of that. Listen, is the whole world going to online sales in retail? Did the whole world go to ebooks? Well, ebooks took up a chunk of book sales, especially in textbook sales. Are all books ebooks now? You would have thought that in 2010, 2005, that would be the case. There wouldn't be a hardcover, softcover book, paper-based book anywhere. Yet they still sell like crazy. So, but there's a mix. And does that mix settle in at? What percentage? 40% ebooks, 60% paper-based, 50-50? Where does that go? And, in each niche that you look at, it might be different. So is all computing going to the cloud? Well, no, it won't. But where will that percentage break down? Will it be 50-50, 60-40, 40-60, the other way? Who knows? It's hard to tell right now. The trend is software as a service, and cloud-based computing has increased dramatically. Okay, where's it going to go? That's the key. So shifting to cloud computing modifies the margin structure for many in the computing industry. It can accelerate innovation, changes the desired skill mix and job outlook for information systems workers, enables organizations to spend less on hardware infrastructure, and reinvest it in strategic efforts and innovation. That's why larger companies might do it. Entry-level companies don't want to invest in hardware. They want to invest in people and product. And if the hardware costs, if their information systems cost them less by doing it on the cloud than owning it themselves, let's do that. Firms need to think about strategic advantages that can be created and what works for them. So what does it take to run this thing? A server farm, a massive network of computer servers running software to coordinate their collective use. You want to provide the infrastructure backbone to software as a service, hardware cloud efforts, and many large-scale internet services. They require plenty of cheap land, low-cost power, ultra-fast fiber optic connections, and benefit from mild climates. So Google, Sun, Microsoft, IBM, and HP have all developed rapid deployment server farm modules. If you look at this is a Microsoft data center in Holland. It gives you a sense of the size of the server farm used. This facility is over 27 acres in size and estimates to have cost of over 2 billion euros. Remember, heat was an issue we talked about when we talked about Moore's Law last week. So know what virtualization software is and its impact on cloud computing, and be able to list the benefits to a firm without using virtualization. So virtualization is a type of software that allows a single computer or cluster of connected computers to function as if they were different computers. Each computer runs its own operating system and software and can be used. So this is kind of like the client-server kind of approach, I think. Each computer runs its own operating system and software and can be used to reduce the organization's hardware needs. Hold on a second. And can create a firm's own private cloud of scalable assets. And cut energy consumption and lower the carbon footprint. Containers, a type of virtualization that allows shared computing operating systems for more resource savings and faster execution. And virtual desktops, running, for instance, of a PC software on another machine and delivering the image of what is executing to a remote device. Now, I'm not familiar enough with these to be an expert, but I think you need to know kind of what we're talking about here. It should make sense if you get in business. The whole point of a course like this is to learn enough so that IT people aren't blowing smoke at you. How's that? So understand the benefits and challenges of app stores and how these products are changing the way we conceive of software. Compared with packaged software, apps lower the cost of software distribution and maintenance. They offer more user interface and integrate more tightly in a device's operating system. Think of your phone, for example. Huge firms have leveraged smartphone apps as their only or primary interface with companies. I would say Amazon's online ordering relies heavily on smartphones. And I haven't mentioned Amazon a lot in this week's lecture. I'm proud of myself. Critics say apps force consumers into smartphone walled gardens and raise consumer switching costs. Well, it's so easy for me to use the Amazon app. Why would I use anybody else's? And if I want to get coffee, I know where all the Starbucks are, and I use the Starbucks app. It's like, it's not a walled garden, but it's like you're used to it. It's like the airline frequent flyer cards. We want to know what the options managers have when determining how to satisfy the software need of their companies. You can also have apps, before we move on, within your own company. You can have people write apps for your phones and apps for that interface with your ERP system on tablets and whatnot. And then you can just access that part of it. Like if you're a salesperson, and if I'm meeting with someone, I could open my laptop and sign into the system and have an order interface, or I could have an app that treats the salesman could be talking with the client, the customer, and open up the sales app. The sales portal, it looks more like Amazon than a computer would, and we can decide what to do. I've seen service repairmen from AB Apt, the really cool and well-run and customer-focused appliance store in Chicago. When their service people come, it's all app-based. I mean, I don't have to sign. I sign their phone, and then I get an invoice emailed to me. It's pretty cool. So these are the kinds of things, not only apps like on your phone for Amazon or Starbucks or Panera or whatever, but apps for my own company to interface with my customers. So know the options managers have when determining how to satisfy the software needs of their company, and know the factors that must be considered when making the make, buy, or rent decision. I mean, it's an important decision. Do I want to make it? Well, to design your own software and apps, it better be pretty unique to your company and provide a competitive advantage that no one else can give you. Other than that, I think it becomes a buy or rent decision for most applications. Where do you make it yourself? If I'm the only person that knows, if designing those kinds of gears, I want an app that does it. I want to make my own software solution for such things, and it's probably going to reside in my computer-aided design systems. And I'm going to isolate that and have great security around it so that it does not get to other people, if that's what I base my thing on. If I'm doing medical research and I have some sophisticated algorithms and chemical processes or whatever, I'm out on thin ice here. This is not what I've done or I'm familiar with, but I might want to have my own applications for those kinds of things. Make, buy, or rent. What are the variables to consider? It's pretty simple. That competitive advantages we talked about, security, legal and compliance, skill, expertise, and labor available, time, cost, and vendor issues. So I'm not going to write my own software. I'm really not going to write my own software unless I know something that no one else knows, and if I can write it and do it properly, I would have a sustained competitive advantage from doing it. And then I'd want to make sure that it's secure. Other than that, I think I'm going to look at time, cost, and vendor issues and skill, expertise in my company and try to decide, is this something that we want to buy and put on our service, or is it something we want to rent as we learn about it? And then you can always switch between renting and then bringing it in-house if you see some advantage. So it's like a make-buy decision when you're talking about, do I want to make my own? Let's say I start a company that makes some kind of product, some kind of new product. I don't have, if I invest in the infrastructure and I have a higher fixed cost associated with it, might not be to my advantage to do it, buy it. My fixed costs will be too high, and my transaction levels aren't high enough to cover my fixed costs. But as my number of transactions increase dramatically, renting it may be too costly because I'm going to pay more for transaction, the variable cost of transaction in the renting, but I don't have the fixed cost expense. I've transferred that to someone else. If you go back here, for 50 million monthly page views, that's a high level. If I want to go above 50, maybe if I go above 100 million monthly page views, well, then maybe if I own the computing, I might be able to do it cheaper than those guys. What do you think? So maybe it makes sense for me to do it, but it has to do with that fixed cost, variable cost mix. Does that make sense? This would be so much more fun in a face-to-face or synchronized, a synchronous class where we could discuss this. And that really is the end of this slides deck. And I thank you very much for paying attention to my my rambles as we go through this stuff. And I hope these are helping you understand, at least from, and probably not too biased from my perspective, on the nature of computing. Thank you very much.